Okay, today we're going to be talking about electricity and magnetism. Okay, so objects can have a positive, negative, or neutral charge. This has to do with the amount of particles within the substance that have different charges. So different particles can have different charges. The two main ones are protons that'll have positive charges and electrons that'll have negative charges. Positive charges, this is containing the whole substance. So if a substance or a thing has more protons, more positive particles in it than negative charges, it's going to have a net positive charge. You basically just add them up and see what charges the object has based off of does it have more protons or does it have more neutrons? I'm sorry, does it have more electrons? A neutral charge would mean if they have this exact same amount of positive particles and negative particles. So it kind of balances out. Its charge is going to be zero. And negative charge, obviously, it'll have more negative particles than positive particles. So objects with different charges, think about magnets. Objects with different charges will attract. So positive object and a negatively charged object will like to stick together, and a two positively charged objects or two negatively charged objects will like to push apart. They'll like to repel. And finally, this brings us to Coulomb's law. This helps us calculate the amount of force between two electrically charged particles. It will also allow us to calculate the force between two charged objects. So what do all these little letters mean? So F stands for just electrical force. We'll just measure that in newtons. K is Coulomb's constant. This is very similar. This is almost the exact same kind of equation. This is the exact same equation, just with slightly different variables as the gravitational equation. But it has a different constant. It has 8.99 times 10 to the ninth, so a very big number. Newton meter squared over coulombs squared. So, but it does have a constant, and then the two particles will be multiplied by the constant, and all of that will be over the distance squared. So you have an inverse square law going on. So let's do one of these equations really quick so you can kind of see how to plug them in and what they look like. Let's see, two particles are 0.055 meters apart. Their charges are 2.5 times 10 to the negative 6 coulombs and 4.3 times 10 to the negative 6 coulombs. So find the force between the two particles. Okay, so let's just pull all the information out of the question and into the variables here. So for force, that's what I'm looking for. I don't know what it is yet. My constant is always 8.99 times 10 to the ninth. My charges, it doesn't matter what order I put them in because they're all just multiplied together. So I'll just take the first one, 2.5 times 10 to the negative 6 coulombs. The second one will be 4.3 times 10 to the negative 6 coulombs. And then my distance was 0.055, or I believe that's 5.5 centimeters. And I need to make sure when I plug this into the equation, I square it. Okay, so let's do that. So here is my constant, my K, I've plugged that in. My two charges I've multiplied here, so 2.5 times 10 to the negative 6 and 4.3 times 10 to the negative 6. And then on the bottom, I've squared my distance. So 0.055 meters squared. Okay, so let's simplify the numerator here by just multiplying these three numbers together and canceling out my coulombs and divided by coulombs squared. So that would give me 0.0966425. I'm not rounding yet. Newton times meters squared. So I got rid of my divided by coulombs squared by multiplying by 2 coulombs. So that's how my units ended up with just newtons times meters squared. And now I'm dividing by meters squared, so I need to square the 0.055 meters. So if I do this number in my calculator divided by 0.055 squared, I will get an answer of, I think it's like 31.9, but it's going to round with two significant figures to 32 newtons.